Very warm welcome from my side. I'm Anne Wendel, working for VDMA, the Machinery Industry Association, and I would also like to welcome my 5 panelists, experts on the topic that is going to be discussed now, embedded vision and deep learning. What's ahead of us? So I guess it's the best way you introduce yourself because you know yourself better. So the first question is, could you please describe briefly the company you work for and how you deal with embedded vision and what's your view on it? So Paul.
Thank you very much. So yeah, my name is Paul Maria Zaluski. I'm working for Allied Vision Technologies and I'm responsible for the product management. Allied Vision traditionally is coming from the machine vision PC-based market, and since approximately 4 years we are looking into embedded vision, and our mission is to bring all these advantages and technologies that we gathered in the past 25 years into embedded vision, so also the embedded community can benefit from these technologies.
Thank you.
Hello everyone, I'm Michael Gelda and I'm VP Business Development at Antmicro. Our company is driving open source innovation and software-driven methodologies in various areas, including software FPGA development and vision, deep learning. We have been working with companies like Allied Vision, for example, developing embedded applications of their technologies, building out new tools and methodologies to help people take advantage of new computing platforms like RISC-V that are popping up and changing the face of vision. So very excited to be here today. Thanks.
Hello, I'm James Tornes from ON Semiconductor, and ON does a lot of different things about power components, analog devices, but I'm from the image sensor group. We make a very broad portfolio of products that are used in all kinds of applications in vision, including embedded vision applications.
I'm Jason Carlson, and I'm the CEO of Congatec. Congatec is an embedded computing company that has been delivering module-based solutions for x86-based platforms and ARM-based platforms for 15 years. And I would say while we have historically maybe had systems sitting alongside something with vision, what we're really seeing now today, and we are showing this for the first time really big this year in our booth, is with the AI or machine learning that's really going on, requiring a lot more compute power with vision, we're seeing this marriage of embedded computing and vision systems together. And so we're actually have some things together with ON and Basler that we're showing in the booth today. So.
Last but not least, Olaf.
Yeah, thank you very much, Anne. My name is Olaf Munkelt, Managing Director of MVTech Software GmbH in Munich, Germany. We have been involved in embedded vision since more than 15 years. By that time, customers were asking us to bring some of our algorithms to an SH4. So it was a very popular, and still is in some applications, very popular CPU. They wanted to use it for machine vision optical inspection. So nowadays we see many more applications from different areas. Our software runs on much more than SH4, I have to say. But we will see and hear more about the applications anyway.
Thank you. 2 years ago, VDMA partnered up with the embedded world and organized a panel discussion on embedded vision for the first time. So we are now standing here for the 3rd time. A lot has happened ever since. So my next question is, in the few past years, many new applications have come up. And when you walk around through the embedded world, you see a lot of applications at the booth. So embedded vision has conquered also the embedded world and the world, so to speak. So looking back, what has happened since then? With regard to embedded vision, which new technologies have you seen that help to develop embedded vision further? Who would like to answer?
Well, a couple of things, of course. So when I'm looking back in the past years, what we see recently, even in the past months, that more and more companies are releasing sensor modules. So that means sensors on PCBs and then still using the image processing on the embedded board. So, and there are companies that have the vision to shift image processing back to the camera to take advantage of it. And another aspect is that a lot of AI chips are coming out. It seems like the whole industry is jumping now on this topic. So all the semiconductor companies are also competing now to find the right technology. And yeah, that's one or two aspects of the whole thing currently.
I would indeed stress the AI accelerators aspect, especially today. We're seeing quite a lot of them pop up again, even on the show floor, from Google, from other people. But also, I would mention RISC-V, which is enabling a whole area of innovation where people used to think it's impossible to build your own chips, it's impossible to innovate on the hardware side. You just kind of miniaturize the chips more and more and more, and that's enough. And now it's more about openness, about kind of adapting the platform to the applications. It's about building new constructs that answer specific needs better. This is a very exciting space that's growing very fast. So I would name that as the single biggest change.
So we see that smaller pixels are coming out, and that is enabling smaller cameras, but at the same time we're also able to reduce noise, so it requires a lot less processing to do some of the applications that are out there. I think the other big change we see is that the mobile market really has changed, right? You see now we have a lot of phones that have multiple cameras on them, and that's driving huge compute needs on the phone itself, and those same processors then can be used in embedded applications. And so I think that's really an enabler for the whole market. We see this with surveillance cameras as well, not just I want to be a camera, but I want to be a camera that detects people or maybe even identifies people. And so that becomes a platform that can be used for a whole host of applications, not just a security camera.
Anything to add?
I think for me, a couple of years ago, we were seeing a lot of interest in, hey, we've traditionally used USB cameras, but now we want to use MIPI cameras because of the price performance is so attractive. But when you think of our customer base, they want longevity. And these MIPI cameras aren't around for 10 years or 15 years. They're on a very fast cycle. And so this was a challenge and a hot topic a couple years ago. But now today, when I look at what we're doing, and this is what I mentioned, is imagine a system where you've got really, and Intel refers to this as workload consolidation, where you've got on one board, you've got one core of a chip being a gateway, one core of a chip being a real-time motion controller, 4 cores of that same chip doing serious image, facial recognition, age recognition, mood recognition, direction, and this is all in one system. And this is, I think, to one of your points earlier that you had asked me about is, are these systems too expensive? When you consolidate all these functions into one, I think this is really going to change what can be done in the embedded vision world.
There's an interesting point. You all mentioned that. We have more components now. The components have been developed further. So they have less noise, they provide a higher bandwidth whatsoever. We have some specialized processors. What actually I am missing in this scenario is a kind of blueprint, a kind of template, where customers actually know what to select and how to combine, and know that these components work. So in other words, they have something in their hands where they can set up an embedded vision solution easily. And if I walk the show here, I again see all these components, but I don't see, I'm here, please help me, I help you, and I know exactly how you can set up an embedded vision application.
We're all idealists, right?
The background of my point is that we see people coming to us and asking for such and such algorithm and such application. And all of a sudden they ask, can you advise on the CPU? And then I have to dig through my, CRM system, and where are all these companies, by the way? But this is not what the customer wants to hear. The customer wants to hear, yes, I give you the entire system.
I completely agree with you, and I would say our view is, we're in the beginning stages of this, right? So this is not a mature, defined market that like, here's a standard, if you want to do this, here's what you do. And so our view is, it doesn't make sense for us to go from being embedded computing guys to being vision experts. That's not who we are. It's all about creating an ecosystem of partners, whether that's camera, whether that's sensor, whether that's software. But together as an ecosystem, I think we have the best chance of helping the customer get their solutions to market faster at the price and performance targets that they need. And this for me is what we're trying to do, and I think the right way to go about it.
I think that it's only going to get worse in some sense in the coming years, because we're seeing this explosion of different platforms. And
so you're an idealist but not an optimist.
Yeah, I'm actually looking at the long term. So in the long term, I believe it's feasible, right, to achieve this. But right now we're seeing, so many different new exciting technologies, and people are trying to use them. Obviously, you can't blame people for trying to get the latest and greatest technology. But as a side effect, you get a lot of confusion, a lot of people just not knowing how to use it. And there is no single element that's gonna make it all work suddenly. And we can see the entrance of players like Google or Amazon or other big ones, driven by the automotive investments everyone's making, or mobile phones. That has been a factor playing a significant role for many years now. We can see all these players enter the market, and they're not necessarily making it easier, because of course they're new, they have new ideas, they kind of throw their own thing into the mix. I think that there's a big role of the ecosystem, as you said, and especially open source to play in all this, because we can only get testable and kind of shareable components that we can really reuse a lot, I believe at least, when you look at it mostly as an open source development, where you can more or less grab your stuff from GitHub and make it work, whether you're a hobbyist or you're a serious industrial player. You're using the same thing, and there's millions of people using exactly the same code base, exactly the same components, and making it work. I think that's realistically looking forward to, not just 1 year from now, but many years from now. That's what eventually we're going to converge towards. But it's going to be a very long and bumpy road.
Yeah, we're spending actually a lot of energy and resources in trying to connect the ecosystem together, right? So we provide sensors. We don't do a lot of processors. We certainly don't really do much in the AI world, right? But we're trying to figure out who are the other people that these customers that we have can work with, so that they can actually put a system together. And we are making modules. We're not a module maker, but if we can provide modules, that you're going to eliminate one other barrier. They don't have to figure out lenses. They don't have to figure out how to actually build that piece. And so that's one of the things we're focused on, is not just how can we make the best sensor for your application, but how can we enable you with other partners to actually come up with a solution.
And I would like to add some things to your statement. So our experience so far with our customers, they think they just buy a sensor from a big distributor, a big electronics broker, and you just integrate it, put it on the PCB, and it's working.
Luckily.
Then you have to pay hundreds of thousands euros for consultancy at the end. You need to make sure the sensor alignment is accurate, the mount is accurate, you're choosing the right lens, for example, and you need to deal with image processing. And a lot of people out there want to focus themselves more on more fancy stuff, let's say on deep learning, AI, stuff like that, but image processing is quite new to them, so they need to deal with it, and they need partners that can take this over and lower at the end the efforts and the NRE costs in general from the development. So I also agree that we must work together on this one, on the ecosystem. In addition to Michael, who said open source is one big thing. Yes, I agree with that.
They're not contradictory, right?
Yeah. And the other one is just clearly go for standards. So today we're seeing MIPI CSI2 as a predominant interface. The physical layer is standardized, but the rest, when it comes to the MIPI driver, the BSP, every time the customers touch these two things, once they change the sensor. And we must work on this to make it more easy to the customer, like Olaf said, to integrate embedded vision for the future.
Thank you. I think in 10 minutes we covered all. Yeah, many very important points, but allow me one question. I mean, we have been talking about technologies and that we all need to work together. Well, I'm an economist, so my question is, I learned a market is developed by applications. So are there any new applications around? I mean, I know a lot is top secret, but is there anything you might want to share? Any promising new applications?
I mean, I'll share one, and we actually have a demo of this in our booth, and We're not saying who the specific customer is, but I can tell you somewhere in the world we have a customer that's working on doing this, where you'll go into a retail store and you put your items in the basket, and it's not scanning the barcode, it's taking an image of that, it's got artificial intelligence going on and machine learning, and it's doing all of this, and it's literally computing a confidence factor in what that item is, and you literally will walk out the store with ever stopping at a cash register. So it's real time, everything done, security, you know, this is a big one.
That's Amazon, right?
I can't say. But I will say this, your comment, you mentioned a couple of big companies earlier. I was at one of them just last week. And what I think is actually good about them is they are really bold in driving really high levels of performance at volume applications. And what this does is it really drives knowledge, experience, and actually price performance points for the rest of the industry in a way that's actually good. And so I'll share with you, in this specific system, their limitation wasn't the camera. Their limitation, they believe, is how many gigabits of data out at what rate can I get because I want to be streaming so much data. This is the limiting factor for them and what they can do. So this, to me, I mean, this is really, I think this is driving the industry, this kind of thing. But
yeah, but it really is a question there is how can you do more locally so I don't need a fat pipe, right?
No. This is at a local system, I'm saying. This is local compute. So what I'm talking about, so you've got cameras going into a computer that is just taking all this data and downloading it to some storage mechanism, okay? And it's doing compute in real time, but then somehow later that data goes somewhere else. But it is doing local compute.
Yeah. But I think the real question still is, how can they reduce that even more by doing more compute locally, right? To only download what's really interesting and needed, right? So I have surveillance cameras in my home, right? And right, a doorbell. But they send the data constantly to the cloud, right? And so I can only get, you know, I have 2, and I'm probably at my limit of what I can upload, right? So, you know, how can I do more locally so that I don't send all that data to the cloud? And I only send, here's a face. Could you please help me identify it, right? But I've already detected that it's a face, right, perhaps.
But again, doesn't it add more value for you to say, you know what, I actually want to know whose face this is?
Oh, absolutely.
Are they a criminal?
And my camera
does that,
not. Right? Yeah. Yes.
Is it?
No, so.
Then you have to have a local database of criminals. It gets difficult, but you can definitely do this.
The more data you can capture, the more value there's going to be.
Absolutely.
You'd love to know on that image if there's like rain pouring off your roof and maybe you've got a problem with your house. Sure. I mean, so I view it, and again, I realize I'm coming from the computing point of view, not from the camera point of view. But I'm a believer, and this to me is what's exciting about the whole digitization trend, which I personally think video is the biggest thing behind that because it's going to generate more data than anything else. Is there are completely new business models that get created as long as we can cost effectively deliver all this data that you can then do something with.
Right.
So allow me one question. I mean, you mentioned 2 guys are from the traditional machine vision industry.
Sorry.
So there the system architecture is still predominantly PC-based. And of course, it's machine vision is a booming industry. So we have around 2.6 billion euro turnover generated per year. Growth of 10% on average for the past 10 years. It's a booming industry, but rather small. So the core component of an embedded vision system is the processing board, and you mentioned it to stream data and so on. So the question is, what would you say to these fellow guys? Can embedded boards with supposedly limited processing power, so can they replace powerful PCs?
Can I answer that one? Because
yes,
actually, you asked about cool applications that are coming, and I think portable computing and miniaturizations is the fascinating area that we should be looking at, especially. We have a customer doing augmented reality with both like enhancement of the vision in front of you, as well as eye tracking at the same time. So you're able to not only just see the world in an augmented way with some extra information, like you can see that people in this audience are perhaps bored looking, or some other things, but also you are able to navigate your field of view, whatever you're looking at, kind of take some decisions with your eyes just by looking at certain elements of that vision. And this like wasn't possible before without connecting it to the cloud, right? But right now you can use something like an NVIDIA Tegra X2, for example, that's in a reasonably small form factor, and you can run it on the battery. Sure, it won't run for days, but it'll run for enough for people to care. And you're able to build all those, Magic Leap and other companies doing this exciting new computing platforms, I would say, that allow people to interact with computers in a new way. I wouldn't compare it directly to the smartphone, of course. Everyone keeps kind of saying, what's the next smartphone? I don't know if it is the next smartphone, but certainly we're seeing a new kind of wave of devices before us that are going really to drive costs down, miniaturize sensors, et cetera, et cetera.
Yeah, and I think there's tons of investment of new companies that are working on AI accelerators or ways to reduce the network, prune the network, compress the network, right? So if you really go out and survey the companies, and a lot of these are driven from the automotive perspective, but they're not specific to the automotive, right? And so I think you're going to see a whole new breed of chips that are going to be available. They're going to have fantastic capabilities, and they're going to be reasonable power, right? And are actually going to displace PCs, definitely.
We're helping build some of them, so yeah.
Yes.
So let me come to this machine vision topic. Sorry to bore you.
You know, we are the old guys.
Yeah,
so.
Gentlemen, I have to disappoint you a little bit. You can build super duper chips for AI networks, but they will be completely nonsense if you want to read a barcode. So we have to accept that there are applications where you can live with a standard ARM CPU, where you can live with standard algorithms which provide sufficient power, sufficient correctness, and so on. So you pointed this out a little bit. You said that if we can handle the amount of data in whatever application, and I would like to link this a little bit to the machine vision industry, which has been handling lots of data in any case. Today, I think latest cameras have 72 megapixel, something like that. So, you know, it's more about are you able to process all these data in a sufficient time frame? Or you have line scan cameras which sends kind of sheets which runs at whatever 10 meter, 20 meter per second or so. So for all this kind of applications, you need to have a PC architecture or sufficient powerful architecture. And usually you need to have a kind of complex setup in terms of the camera has to be able to use the lens correctly or vice versa, so the optics, and of course you have to process that data. So I'm a strong believer that the machine vision part still will survive in terms of standard architecture, in terms of standard applications.
So I don't disagree with you, but I would make a subtle difference, and that is that I think all the needs you mentioned are there. But to really drive price, performance, size, power, all of this in a system, instead of having this computer that has its cost and all of this associated with just the machine vision system, if that function can get combined with other functionality in the system, all on one chip or one computer, this by far drives a better level of price performance.
So you are the optimist.
Maybe so.
Yeah, I would also like to comment on this one. So I had a discussion with our sales team some years ago when I selected the first sensors for embedded vision, our new Alvium camera series. And everybody was complaining because They're coming from this PC-based machine vision. They're saying, we need high resolution. Our customers need high resolution. But I told them embedded vision is completely different. They are happy with HD and full HD at the moment because they simply cannot process more. So if you ask a customer right now, do you want 4K for your application? He will say, yes, of course, immediately. But then he realizes he needs to figure out the algorithms, he needs to program everything, and then he finds out, oh, my CPU load is exploding, or I'm using the GPU partly. So there's one limiting factor currently, converting PC-based to embedded vision, which is clearly the resolution currently. But if we gain more efficient processors, more efficient embedded boards and computer modules, I believe this would be a dramatic accelerator for the shift. On the other hand, from our industry currently, where I don't believe embedded vision can take over where huge data is handled. For example, for the display, the flat panel display inspection, for example. Nobody would use at the moment an embedded board for it because you have so much data that needs to be proceeded. So I would not expect embedded vision will take that over in the next years.
I would have two comments to that. So first of all, we're talking about x86 versus ARM.
It's not. We do both.
Yeah,
so
yeah. But
the demo I mentioned with the checkout system, with the Bosler camera and the on sensor, is actually on an ARM solution.
Yeah, so I'm saying that it's not necessarily a juxtaposition,
yeah.
And also we should be looking at new architectures like RISC-V or MIPS that just recently got open sourced. These people, like RISC-V, us also, we're a founding member, we have the ambition to also cover higher performance sectors. It doesn't mean that everyone building new platforms will just be aiming at the small embedded boards. There's also going to be, like you could see Microsemi and Sci-Fi demonstrate an RISC-V-based PC recently. And of course, it's not a PC in the x86 sense. It's not compatible with the software, so that's a major problem to be solved. But on the performance side, it's not just aimed to kind of replace those mobile phone chips. It's also aiming higher. That is kind of the one thing.
So maybe we can agree, for the time being, yeah, we can agree that it's not for sure which system architecture is going to prevail in the future. So for the time being, we say it's embedded and PC-based. So maybe
I don't think anything will prevail.
No,
I don't think it's not just one against the other. The PC market will stay, it'll grow even, but everything will grow. There'll be so much growth that there'll be room for everything.
I completely agree, but here's my really simple analogy. I was just thinking of this while we're sitting here. So we all used to walk around with this dedicated box called a camera. You guys remember this? We all had cameras. We all now have cameras, but they're not just a camera. Yeah. And there are people who still buy cameras and are passionate about them and use them and have all levels of performance. And there's going to be these dedicated things like a camera for machine vision that do this very specific job. But what's going to be explosive and disrupt vision as we've known it in the past is this thing that does all these things replaces the camera. And this is what I'm saying. And I don't think we disagree. I think.
Okay, so, and as I said before, it's the demand. It's demand-driven, and we'll see. So maybe in 5 years, I'm going to ask the question again, and I'm looking forward to your answers, okay? So we just learned that, or we are aware that future applications, there's a huge chance for all of us, will be based on embedded vision, small integrated image processing systems that work intelligently and directly from machines and devices. Yeah, so wow, that's a nice dream. Or we all see it today. And we learned that thanks to standardized interfaces of image sensors, embedded boards can process an increasing amount of data in real time. Yeah, so great. So, and now, equipped with artificial intelligence, let's move to the second part of our discussion. Equipped with artificial intelligence, image processing systems are becoming even more intelligent. They learn for themselves. So, machine learning and embedded vision, an unbeatable team. So, what are the challenges that need to be overcome?
The one big challenge really is that people don't really understand what those new deep learning algorithms do. They're awesome, we use them a lot in everything. It's a great new approach that solves lots of problems. But there's a little warning light where, you know, people don't necessarily kind of know where their algorithm is coming from, what it's exactly doing, and why it's doing so well. So that's a challenge, of course, not just for the vision industry. It's just a broader challenge for the industry at large. But I would kind of name it as something that we need to address, especially as we're using vision to, say, do homeland security stuff, you know, kind of deciding whether a certain person is supposed to be stopped for searching them for potential, you know, terrorist activity and so on. What are the deciding factors? Why him or her and not somebody else? So this black box nature of machine learning today,
Black box, yeah.
It's kind of problematic.
How would you approach it?
Well, you would probably guess my answer. I'm all pro open source and openness, open research, right? That's the only way. But it's not. The answer is not only in open source, because of course it's also about states and governments funding research to try to explain vision, deep learning in vision, right? It's about kind of having dedicated efforts, and these are not going to come from companies, right? Because commercial companies don't really care about this aspect so much. So we need state-funded research to kind of look into whatever deep learning is doing and how to make it more approachable to humans, I think.
I think we have two parts which we have to take into account if you talk about deep learning. One part is the algorithm part. You can open source that. The other part is the data itself. And if I look at both parts, probably a couple of years ago I have said the algorithms are more important. Today I think the data is more important. And data, unfortunately, is not open source. At least not the way probably people wish it should be. So we have to take care about copyright rights. We cannot simply download images from the internet, put them in a network architecture and hope they get good results. So we have IP issues here where we have to have a close look. And if you look at the automobile industry and how much effort they spend to build up data sets, then you can get a guess where the value is. It's not in the algorithm any longer, it's in the data and in the way how you treat the data. And I think we have not found a good answer so far how to help people to build these data. We have found answers in the domain of machine vision. Our company, for example, has set up pre-trained networks, which allows our customers to just add a few hundred images and then make this network work for their application. But this is a domain-specific approach. So the automobile industry does also do. So what I'm saying is we have to think a little bit more about what data is and who owns that data. What we know from our customers is they want to own the data by themselves. So even if they use our pre-trained network and tune this network for their application, we think this is their data, so this is their network, and they own this IP so they can develop it further. Because all these guys have very specific knowledge about their processes.
So I'd like to make two comments, one related to yours and one related to yours. So I think that's an interesting idea of like who owns the data and what is the data and the IP rights. And just an example, when you think about that, we have a customer that for police systems has body-worn cameras, right? And so they're wearing this camera and you've got a crowd and something happens and so they're filming everything. But the laws say you have to blur the face of every single person except for the bad actor in the crowd. This is real. And so here's an example where a few years ago, they would get all this video and someone would manually sit there and do this redacting, video redacting. Now with compute power at the right price point, this is being done on the fly. So it makes this way more valuable, way more usable. But it's a thing about who owns the data, right? And just the laws are like, technically, we can't have a video of this whole crowd running this way. It's against the law. So I agree with you. I think that's an interesting point. On your point, I have a challenging point of view on the government part. I believe that industry will drive these things, and industry needs to drive these things. And the reason why is in the industry, we really get challenged with, we don't take on huge development projects unless there's a business opportunity there. And the honest truth is, whenever I've been given some money that I don't have to work so hard for, my decision about how to spend it is more careless. And I think a lot of technology programs that get government funded don't result ultimately in high volume commercial success for this reason. So my personal belief would be industry is going to drive the price performance of this. I
agree. I more meant supportive role of governments and universities especially. Because,
I mean, I love them. I live in Boston. MIT is an incredible university to collaborate with, right? Spins out tons of startups in its business, but it's,
So I'll add another wrinkle to the data problem, which is that, so there are data sets out there, but unfortunately they're captured with one particular type of camera, one particular resolution, perhaps one spectrum of light, right? And one of the other problems is, okay, now I want to make an application, and maybe I want to use IR. Or maybe I need other things in my camera, and now how do I take and train and have enough data that I actually can do it? So it's actually, I agree, the data is actually by far the hardest problem.
This is an interesting point. Augmenting data also with other, say, frequency spectrums, and you can imagine more stuff. Probably know all these sequences where they colorize black and white movies. So you can continue this sensor fusion idea. And I totally agree. This is an open topic, yeah.
And for that, we need open standards so that people process data in similar ways. So I don't see any kind of juxtaposition between open data and closed data, because they should coexist. I believe that we should, as an industry, kind of come to some standards. How do you handle data in general? And then there's some example stuff you can work with, on the web. And of course, there's a lot of people who will have their own sets of data they secretly kind of want to guard against other people looking at them. So open standards are the answer, but it's not an easy answer.
I remember what you said. You are an idealist. I, too, am a believer in standards, but the reality is, in every industry I've ever been in, there ends up being competing standards. We will not live in this ideal world of there will be one standard for video data across everything, I am convinced.
XKCD says that, right? It's a comic. There's so many standards, we have to have a new one.
What is with usability of vision systems? Does machine learning help us?
Say it again, Anne.
Embedded vision and deep learning, does it help for the usability of a machine vision system?
Of the visibility?
No, of the usability.
Usability, usability, visibility, yeah. So, it does help to a certain extent. But I would like to come from a different angle to this topic. We call this artificial intelligence. I guess everybody of you sitting in the audience would claim I have no artificial intelligence, I have natural intelligence. And I would like to use it. So what I would like to motivate you is to have a look at what other people say about that technology, about artificial intelligence. And there's a very prominent graph, which is called the Gartner hype cycle. Who knows this Gartner hype cycle? Ever heard about that? Some people know very well. So it basically draws a curvature and says, okay, we have expectations. If a technology is very young, we probably have very little expectation. At one point, we have very high expectations, but unfortunately, we have no commercial success. And then this curvature goes down because all expectations are kind of liquid. They are gone. And everybody thinks this technology will never come back. Ha! And then it comes back at one point because somebody found the point where he can make up a business model out of that. And the interesting point is you have so many new technologies like, neurons tracking in your brain, like blockchain technology and whatsoever. Autonomous driving is also one of them. And you have machine learning. So machine learning, since 3 years, has moved only a little bit from the peak down to the tail of no expectations any longer. So what it means is there are super duper intelligent people who think this technology is over-expected. People expect too much from this technology. And I think we still have this case. We have to look very closely for which applications does it deliver a benefit. It delivers a benefit for the applications in the retail store, which you said. It delivers a benefit for the automotive side. But there would be more to argue about this, yeah? Because they started originally from a completely different angle. So they were trying to come from control theory to describe the outer world in front of a car. And still they use parts of that. So what I'm saying is we have to have a closer look at each application and find out whether it adds a benefit or not. And for me, it's not a clear picture. I argued already you will never use an AI chip for reading a barcode. But you will also not use an AI chip for performing a sub-pixel precise measurement. Nobody will do this. Because at the end of the day, you have to handle the wafer in the machine with nanometer precision. And AI does not get you any benefit. And so we have to cross all these applications. And some we have added value and some we don't, we have nothing.
So Olaf, what you mentioned about the exaggerated expectations of deep learning, like it's going to disrupt everything and help to solve the world, so to speak. So it comes comes hand in hand with your argument that what really is deep learning. People need to understand what the benefits are. So thank you. Yeah. Okay. So. We mentioned machine vision, the standard players. We mentioned the embedded community coming into into embedded vision. So, are the new competitors for you, yeah, for the standard machine vision industry? Are they coming from the embedded community?
From both sides, I would say.
Okay.
So, first of all, from the embedded side, you have raised your nice smartphone. To the audience, everybody has a MIPI CSI2 camera in their pockets currently. So these manufacturers are also part of our competition in the future.
But also vice versa, I guess.
Vice versa as well, but I want to comment on the first one. We should not make the mistake of comparing apples and pears, because our modules have technology on board which is extensive image processing, so we can take over all the pre-processing and advanced image processing on the camera. The other modules from the smartphone are focused on mobile industries. They are more focused on the demands that we as consumer have in our daily lives. So it's not necessarily something that is interesting, for example, for machine vision and factory automation. So these are two different technologies currently, and at the end, the application must decide for sure. You save some cost on the embedded board side because you don't need necessarily an ISP. On the other side, you have increased costs on the camera and vice versa, so the application decides. In regards to the competition from our machine vision industry currently, yes, of course. I see it, especially since the Vision Show. There are 3, 4, 5 companies from the classical machine vision that jumped on the train of MIPI CSI2 sensor modules. So there's still the sensor on board on the PCB. The image processing is still done on the embedded board. And we now see some movements also that some of these companies also add some image processing functionality on this sensor module. So I would consider them to call them camera modules then.
And what about maybe a third player that might win the race? I mean, the internet giants are also here.
The internet giants, is it?
Yes.
Like Apple, Amazon,
Google, Amazon.
And all these guys.
But as it relates to machine vision, you're asking?
To embedded vision.
I think, in my view, there are going to be things like in the camera where there will cannibalize certain things. But there are absolutely application-specific things that I just can't imagine them touching or getting in the business of. And for me personally, I do not see us in any camera sensor-related guy whatsoever as a competitor. Our view is we're the best at what we do, and we just want to partner with people who are the best at what they do. And we see the intersection of these technologies as super exciting, right? And our challenge is to really bring the simplest solution that gets them the fastest time to market at their price and performance. And it's up. And if we can do this together rather than they have to find all of us individually and go back and do this, this will speed up the market and the growth of the market and all of that stuff. So I'm really positive on that. I wanted to make a somewhat provocative comment. So I agree with you that you want a specific type of camera to read a barcode. So there will always be that type of camera to read a barcode. I would hypothesize that at some point in the future, barcodes won't be needed, because there will be enough intelligence that why would we waste the time and money to print this thing on here? We know what the hell that is. We know what it is. We know how much it weighs. We know what temperature it is. We know we know everything about it.
Well, in theory, I would agree, but in practice, I think this will be a time frame of 30 years or so.
Okay, you set me up perfectly. So somebody just said this to me last night at dinner. If you are complaining about how fast technology is moving and keeping up with it today, it will never be slower than it is right now. Right? The rate of advancement is escalating. And it's incredible. And again, 40% of our customers are industrial customers that make products that they want to sell them for 20 years, 30 years. And so I talk to them and they're like, we have to support this for 30 years. This is really important. And I say to myself, looking at 2019 for the next 30 years, do we really believe 30 years from now anybody is going to be using some kind of system that was designed today? This is going to be like 4 orders of magnitude performance behind what is happening then. I don't believe, and this is my point about it is escalating, this rate of advancement.
The acceleration rate, I agree, is very high, and we're probably beyond Moore's law in that regard. Yeah. Step by step, we have to take these opportunities, so to speak. So I don't think it's necessary to have the same system for 30 years in your shelf. No need for that. But what we need to have is interfaces which allow us to let systems communicate to each other. And they should be kept as long as possible, because then we can hook up a much more powerful system, providing even more functionality than the original system. So we should concentrate more on the interfaces.
Interfaces and standards, as mentioned. Yeah.
And here I agree. I mean,
I actually, thinking about what you said, what kind of competition are we facing? I think that you mentioned the internet giants, and then we said, well, they can't possibly get into certain areas, which I agree with. But what they're really doing is they're pushing up the bar much higher, so that people expect more, and they come to the industrial market asking for like those kind of super duper megapixel sensors from their phones at the price point of a Raspberry Pi, right? And then you have to explain to them how it's not that simple. So I would say that we're competing for mind share in a sense.
So they help. They help.
But this is exactly my point. And so they want that performance at the price of a Raspberry Pi, and we can't deliver that. But if we can combine this vision thing with something else that the system is doing, and now you can give them that performance for a small amount of added cost, where it's just a piece of that system. This is what unlocks that problem.
Thank you.
And really, the giants are going to enable and show people what is possible in some of these areas and really push the whole market, right? Like the example you said, where you can walk into a store, pick up something, put it in your basket, and walk out. And that's just an example, but that same technology could be used in lots of different applications. It doesn't have to be a grocery store.
Absolutely.
So I'm not saying it's a bad thing, but it is a phenomenon.
Okay. So we would also like to allow maybe 1 or 2 questions from the audience. If there are any comments, questions. Yes, please.
So I respect and am very interested about the rate of change and the accelerating technology. But can you maybe talk a little bit about how quickly people can adopt? In the sustaining world, I can imagine that there will be defense applications that may actually be designed today, but still be in activity for another 30 years. So maybe you could talk a little bit about how we as people and society can actually embrace and kind of get on this rocket ship of accelerating technology.
Difficult question. Ethical, legal, and societal questions, huh?
I think it's all about ourselves. So if we walk in a shop and we have this, retail automatic checkout system, everybody will be happy. If we talk about this body camera, we probably appreciate that all faces are blurred, which have nothing to do with the scenery. But by the way, who decides who is part of the scenery? So we already have this dilemma, and I think you have to go there step by step and find an answer. I don't think there's a general answer from my point of view. We all wish we have to have a general answer, but this is gone since we have lost our king in Germany, and this is 100 years ago.
I think this is, you have the ethical part of it, which is always tough, and it's way beyond my pay grade. But then you have just the human personal part. And for me, I think we make this trade-off of maybe there's something about the technology that I'm not so comfortable with or not so crazy about. But if the benefit that it brings is good enough, I accept that. An example would be for me, like in security monitoring systems, none of us probably like the idea of we're walking down the street and everything is always being filmed. But if as a result of that one day we had 100% coverage of that, overall crime in the world went down significantly because they could absolutely, monitor, be proactive, produce. You might say, I hate this that they know I went to the liquor store 3 times yesterday. But if my family, my children have no problem walking to and from school and they're safe, we accept this. And so that for me, it's the benefit versus the negative. And that's, I think, the challenge.
There's one question, the last. So.
Hi. Many people talk about sensor fusion when you augment your video stream with depth maps or with hyperspectral imagery. What do you think about such possibilities of that technology?
Sensor fusion.
Yeah.
Can you repeat?
It's about sensor fusion, hyperspectral
Yeah, I understood
imaging,
that you want to combine different sensor data from different sources in order to accomplish one application. And hyperspectral was one of the applications. I briefly came across this topic. I think it makes a lot of sense, but we don't have a clear picture yet what the actual benefit is. So I know that our customers are working in this regard, also combining X-ray information within an AI network with image data. So I think it's a journey. It's more a tryout. And it's a tryout because, and this is very funny, usually you would have not done this ever before because physics does not allow you to do this. This is a contradiction in itself. However, there may be structural information in one frequency band which has a correlation to structural information in the other frequency band, which nobody actually know, or it's too complicated to describe in physical terms. So people try it out. It's a journey. And I don't know what the result will be.
But don't our bodies do this?
Yes. And I actually think this is happening, right? So you see this in automotive, right? So it's not this market, but already in automotive. And why do they do it? Because they get more information, right? So my image sensor is great. It's the only thing that can see the road markings on the road or what color the traffic light is. But what happens when it's foggy out? Well, my radar can see through the fog, right? And so I can still drive in that kind of condition, or provide safety functions, even if it's not driving, that I can't get with just one modality, right? So I think we're definitely going to see this happen. It really depends on the needs of the application, though, right?
But you just mentioned it. We do it as a human. Like, we have 23 sensors altogether, and we combine them to get the data we need.
Yeah.
So to me, it's totally natural, right?
Okay.
Yep.
It gives us our intelligence.
Yes.
If we only had one source of input.
Right.
It gets more difficult, definitely,
Yeah.
and limited.
So we have 5 minutes left. So 1 minute per panelist. Embedded vision and machine learning. We learned a lot today. So it's an unbeatable team conquering new vision applications, making the world easier with smart, intelligent devices that see and understand. So where do we stand in 5 years? Not 30, but in 5. Where do we stand?
So, from my point of view, you mentioned this already a little bit. In the industrial world, and also in the applications beyond that, in pharmaceuticals and medical applications, people still have the impression that the system costs too much. And I think in 5 years, we will have much more knowledge. So the word is out, the people know there can be cost-effective solutions for, what we call today challenging applications. And there is an ecosystem where I can benefit from.
For me, I would say that I think data, and here the data being video or combined with many other sensor input devices, is absolutely the gold. And we have to recognize that people will make money off the data, and that totally changes the price points that they're going to be willing to pay for solutions. So they might have said this has to be $1,000, but I think we're going to be sitting here 5 years from now where more and more models people are using a complete embedded computing vision system, and their business model is making money on intelligence from what they're doing with the data.
Data-driven business models. Mm-hmm.
Yeah, and just as happened for the past 40 years, right? Compute continues to get cheaper, so I don't really necessarily need to be optimized as much to still have an application. So I think we're going to see applications that none of us can even think of today, 5 years from now, right?
Not only in the supermarket, but also everywhere.
Completely agree.
Right?
Okay, thanks. Michael.
I don't know what to add to this, yes. So we can't really guess what's going to happen in 5 years. We can predict some trends. Hopefully, what I see happening is, open architectures, open platforms. I really hope for that to have a profound influence on this market 5 years from now, so that we can really more flexibly, more freely design our devices from the ground up. And since, as you said, the cost will be shared between the upfront cost of building a technology and then potentially exploiting the data that comes with it, there's going to be new applications that are enabled through this that we can't predict, but hopefully these applications will be able to be kind of designed from scratch for security, being better understood. That's at least what we can dream for.
Thank you.
So ideally in the next 5 years, I hope we have built up this huge ecosystem of camera manufacturers together with the embedded board and computer module manufacturers. One aspect I want to highlight is also open source. So we start, for example, to publish our CSI2 driver on GitHub for free. So everybody can modify it. We believe this is the future of it. And besides that, Michael said that in 5 years, so many things can happen. You have said that it will be accelerated like this. So very exciting times for us.
Okay. Thank you to all of you. It was an exciting discussion, and thank you for you staying here with us for the whole hour. So, yeah.